Okay, so today we're going to go over, I'm going to go over how to align to a CAD model using Datum target points and creating a color map after. So we'll start up the Polyworks. This is the Polyworks Workspace Manager. This is the file cabinets where all of the programs can be stored separately. Different workspaces can be created. I've created this one with some samples in here. I'm going to start by showing you a few different scan type examples. Once this opens here. So the first thing we need to do is collect some data by scanning. And I'm going to go over the different types of data. This data was scanned by me with a roamer arm with a laser line scanner. When we start up the scanning dialog, there's some options involved in here, and whether we're going to scan raw points or we're going to incorporate real-time quality meshing. And with the real-time quality meshing, are we producing a point cloud or a polygonal model? So I'm going to show you the differences between all of those right now. This here, what I'm showing on screen, is raw data. So when you look at it, you can see where the scan rate was slowed down and sped up, and you can see the overlap and areas where there's less overlap than others. So this is just all the data collected there. This little patch is maybe 4 inches long. So if we're looking at that, I have that recorded at 324,000 points. That's quite a bit. If you scan a larger, the rest of this part would end up to be 3-4 million points. So in the spirit of saving time and processing, I might want to do something different. So then by turning on the real-time quality meshing, but outputting the points for that, there's settings in there that what it's going to do is create a 3D grid of equally spaced points. So these points are going to be spaced at 0.4 millimeters. So if we zoom in here and look at the data, the only overlap you see are stitching. So it looked at the overlap and it decided on a grid pattern to go there, and the only overlap we really have are the stitched areas. So the point spacing here is 0.4, so the scan size of that is reduced dramatically to 110,000 points. So already I'm going to be saving a lot in processing time by running that algorithm to scan to mesh. The step further in that would be to generate a polygonal model, which then draws triangles across the 3D points and would ultimately look like this. So now the triangles are triangular surfaces and the vertice points are still points. So this model, zoomed out here, has 99,000 points and 196,000 surfaces. So processing this might take a little longer than the previous, which was just 110,000 points. But then in the meshing algorithm, when you complete the mesh, there's an algorithm that runs that will reduce the size of these triangles based on the geometry. So that's my next one here. So if you look at the triangles here, it decided on these flatter surfaces it can make larger triangles, but down here in the details, it retains the tiny 0.4 size triangles. So once that algorithm finished, I end up with 24,000 points and 47,000 surfaces. So that's about a third of what I had in the raw scan of 324,000. So for this reason, most people like to deal with this, this mesh data rather than the raw point data when they're doing their inspections. So continuing on from here, this is what I'm ultimately going to strive for is to make one of these and then align it to the CAD model. So I will open up the next one. Rather than boring you with the watching it scan, I've went ahead and scanned both the top side and the bottom side. I've scanned them as the mesh points, so the 3D gridded points. I did this because ultimately, after I match the two halves together, I'm going to generate the polygonal model mesh. So rather than running process time to mesh this one and mesh that one and then mesh them both together, we're just going to run the points. So the first setup I had on a few pins. I scanned all what I could see on the top, and then I scanned a little bit inside to have some overlap data. I have to remove the fixturing. So in order to do that, I can press the spacebar button, which turns my cursor into a crosshair, or I can use this kidney bean shaped icon over here to the right that's called select elements. And with that highlighted on the left here, I can do paintbrush style, where it would just be a circle that I can drag around and select data. I can do freeform, which is a lasso type, and I can do polygonal, which is just connect the dots, right click when I'm finished. I prefer to use the paintbrush here. I'll just paint that bit there, get rid of that stand, press spacebar or the kidney bean to go back into the mode where I can move the model. In kidney bean icon again, select this data, and I saw this little guy out in space. Hit the delete key. Now I've cleaned up my data. Oh, there's a little right there. Now what I'll do is hide that scan. If I were scanning right now, I would use the Move Device Position button down here at the bottom, and that would create another alignment group. These two scans being in separate alignment groups is what allows one to move separate than the other. If they were in the same group, they would have to all move at the same time. So I would move device, which creates the group, and then I would turn back on the scanner, and I would scan to points from point cloud from mesh again, and this is what I've scanned there. I was able to get all of the inside, and I could see pretty much a good amount of the bottom side from underneath. And I'll also clean up the posts on this data as well. Delete key. So now I have my two separate top and bottoms of my scan. So what I need to do now is align the two. So across the top, if I search for my alignments icon, this one here looks like a cube, a red cube and a gray cube trying to align together. And inside of here, I'm looking for a best fit data to data, not to be confused with the data to reference. So data is scan, reference is a CAD model. So I'm aligning scan to scan, data to data, and that opens my best fit algorithm box. Looking through here, I'm going to pre-align using point pairs because they're not already somewhat aligned. I'm going to data objects to align as I'm going to move surface scan number 2. And my fixed data, well, it says all other datas. It could be specific and say surface scan number 1, but that's redundant because number 1 is the only other one in there. Next is the max distance, which by default is 4 millimeters, and I find that runs pretty well. What that means is when I pick my points to pre-align and it moves the two together, it looks for overlapping points that are within 4 millimeters from each other. So if I wasn't close enough in my alignment, it might not, my pre-alignment, it might not be using as many points. So I need to be cautious of that. I've seen on larger parts that it's harder to get the pre-align so close, so that number has been needed to be adjusted to be higher for larger parts. I mean size of cars or larger. The next subsampling is how many of the points are going to be used. So 1/4 of the overlapping points. So if it finds 100,000 overlapping points, it's going to use 1/4 of that. So 25,000 points will be what it uses in its best fit algorithm, which 1/4 of these points, if I look here real quick, Surface Scan 1 has 556,000 points. Surface Scan 2 has 811,000 points. So if I definitely have 1.2 million points after I make this match, maybe I have close to 1 million that are counted as overlap. Using 1/4 of that, using 250,000 points is going to be way more than sufficient. Below that max angle, it's just looking at those overlapping points. If they're not facing the same way, it doesn't count them, but they'd be facing the same way within 45 degrees. So when I click start, it gives me a split screen. All I really have to do here is get the part into a similar orientation on both sides and pick 3 points in similar locations. So I'll click the pick over here to the left, which turns my icon into a ink pen, and I'll go click on one side and locations that also exist on the right side, and then I click those 3 points. Once I'm finished, I need to right click the mouse. And you see it went pretty fast there. It ran 5 iterations, 5 tries, and it got its convergence really low. Convergence roughly translates to maybe a standard deviation, so it's not how close the points are. Its goal is to get all of the points the same distance away from the other points. So looking at the data, you want it to have this marbleized look here. So I have the green and the purple where they overlap. You could tell they're occupying the exact same spot because depending on which angle I'm looking at it, it's more purple or more green. So that indicates to me that I have a really good match on the 2 halves. So I'm happy with that. I'll close the best fit dialog here. And now that I know that this is over 1.2 million points, which isn't totally horrible, but as far as processing time goes, I want to run that meshing algorithm and reduce it, especially where there's overlap. I only want one set of data at the overlaps. So in my tree to the left here, I'm going to highlight Surface Scan 1 and Surface Scan 2, and I'll right click and I get a menu, and the very top one there is to create a polygonal model. It opens up a dialog here, make sure that I have both scans checkmarked, that I'm going to use both scans. The meshing parameters are from source object, so it's going to use that same 0.4 millimeter spacing to make the grid again, or I could go to custom and I could type that number in there as well. It does have the ability to smooth. I recommend turning that either off or to this minimum number for inspection. Essentially, you could be massaging or moving data. And then there's the reduce, which is where it takes the 0.4 size triangles and makes them smaller. So on low, it says the tolerance is 8 microns. So it is going to allow a point to move 8 microns in order to make a larger triangle. But then also down here, this checkbox checks saying max edge length, it cannot make a triangle bigger than 2 millimeters, the longest leg. I'm going to go ahead and run 5 millimeters. That'd help me get a little less. I've seen this, depending on how rough the surface is, you could go up to 10 or 15 on this comfortably as well. And then I'll hit the create. This process will probably take a minute or two. Does anybody have any questions so far that I can answer while this runs? And there we go. Now it is finished. If I look at it in the wireframe and zoom in here, we'll be able to see that it has made larger triangles in some of the more smoother areas and kept the smaller triangles around in detailed areas. If I look at the count here, we have a number of 434,000 points and 867,000 triangles, and that's a pretty decent size. It's a lot less than a 1.25 million of points. It's down to under 500,000 points. So that's how we get her scanned and get it meshed together, top and bottom. And then our next step would be to import our CAD model. So if I go here to import, down to my CAD model, and then I'll point to sample casting, it brings in the CAD model. I'll go ahead and center on all so that you can see the CAD model is an outer space compared to the part. Before we pick and use datum targets to align these two together, we have to do a preliminary best fit alignment. We need to put the data on top of the CAD model so that it has data to search for and find. So to do that, we would go back into our alignments dropdown, and we would find best fit data to reference objects. Now I'll click that. It's generally the same kind of box as we saw with data to data, so it's asking about pre-alignment, whether I'm going to use point pairs was the only option for the data to data, but with the data to reference, I can use automatic. That's going to work out pretty well for this part because this part is not symmetrical or cylindrical. In those instances, you would have to use point pairs so that the two, you could index the two together because it typically guesses wrong. Reference objects, it's specific to the sample casting.igis, and then my data objects would be surface only, or I can specify, mesh one or all. So I'll leave it to where it was. Again, max distance is after it gets its starting alignment. How far out does it search for overlaps? And it's going to use 1/4 of those 500,000 points to do so. So with this on automatic, I'll just go ahead and hit start. You'll see it snapped right on there. It made 6 iterations before it was happy with the number. And if we zoom in and rotate around, we'll be able to see that we have a pretty decent fit. As I rotate, you can see the yellow and the gray happening. That's a good sign that they're in the same spot. So I'm happy with that. I'll close the best fit to reference objects dialog box, and we'll continue on. So on a print with tooling points, and I'll show you a couple different scenarios. One would be I have 3 A targets, 2 B targets, and 1 C target. So in order to do that, I'm going to go ahead and hide the data. So by over in the tree to my left, if I use a middle click on the feature, so mesh 1 there, if I middle click on it, I can hide and show it. Same with the CAD. And then I also have to the far right here an eyeball icon where I can hide and show the reference, hide and show the data. So I will hide the data because I need to pick off of the reference. Across the top here, there we go. We have a reference target icon. Looks just like a reference target. I'll drop that down, and we have a couple options here, but the most commonly used one here is going to be create surface reference target points. Very rarely would you use one from a feature. You can take them off cross sections, and this bottom one is reference target lines. So that would be a simulator for instance, if the two side locators were just a pin that was perpendicular to the A datum that you press the part against, you would use those rather than it being a pad or a cone tip point that you're pressing against. So ultimately, this is to simulate either an inspection fixture or a machine points for the casting to be set on specific tooling locations before machining. So you kind of want to simulate the same type that are there. For this first example, I'm just gonna eyeball the locations in. I went through here. I don't have a drawing for this, so these would be my absolute numbers for where A1, A2, A3 are, and then my 3 side points or pins would be in those locations. So it's waiting for surface target point number 1, and then datum target label. What's nice about this is I can just call it A, and it's going to auto increment the second, the number on there. The creation method, anchor, I'm going to go pick off the CAD model where I think they should be. Numerically, I can type in the numbers off of a blueprint. From objects would be if I had maybe a circle or a plane that I wanted it to tie to. And then from file, Polyworks does have the capability of if you have a CSV file that has the point locations, you could actually load those in. Alignment direction, I could specify, but since we have CAD, when I pick, automatic alignment direction is going to pick it properly. So what that means is, if we look at the coordinate system of the CAD model, my 3 A datums would be in the Z direction, and then my B datums would be in a Y direction, the direction that the fixture points are facing. So go back into the dialog, there we go. So if I click anchor, that gives me my little pin again, and I can go to picking. So I will pick A1 on this flat right here, A2 over here on this flat, and A3 kind of on this angled surface right here. So this would have to be a conical shape needle type point that it rests on since it's at an angled surface. So those are my A targets. And you can see the symbols in there, A1, A2, A3. And then typically the drawing will have 2 Bs. So if I change to the left here, if I change the datum target label to B before I go pick these, go ahead and click anchor. And then I'll pick my first point. I have them on this side over here, on this side. So I'll pick my first point somewhere around there, and I'll pick my second point somewhere around there. And then lastly, I have to pick my C datum, which would lock in my X direction. So it would be, they would set on all 3 A's, and then it would be pushed up against both B's, and then it needs pushed back against the C datum. So datum target label, I'll go ahead and label that as a C, click anchor, and then I'll pick it right here in the back. So now I have my 6 locators picked off of the CAD model. Next thing I have to do is get these things measured. So if I highlight them on the tree to the left there, I can right click and go to extract the measure. So once I do that, it's going to look at the scan that I have overlaid and return me results. So currently with the best fit, we can look and see how far those are from the virtual locators. So they're off just a little, 0.2 millimeters over here seems to be the worst. So now to complete the alignment, if I go into the alignments drop down again, because I made those datums, I can just tell it to create a GD&T alignment. So down here at the bottom, datum reference frame alignment. So I could just go in there. I have to drop down this creation box. So if I create A, B, and C, and click the create button, that puts it in my list of datum reference frames. And then I can highlight that and click the align button. What it's going to do is it's going to search through and it's going to try to make all of the A datums to read 0 deviation. It's going to move the data to the B datum until they read 0, and then to the C datum till it reads 0. There we go. I'll go ahead and close this alignment direction box, and I'll show the data again here. So looking here, all my A points read 0 deviation. So they're resting perfect right at those locations. Same with B, same with C. In other scenarios, if I had more than 3 A's, it would need to average. So one of them wouldn't read 0. It would need to best fit the A's together, because a flat with more than 3 points isn't, unless it's perfectly flat, there's no way you can make it touch all 4. So that's how to make a reference points alignment using datums picked off of a CAD model. I'll go ahead and head out of this one. Let's see, probably, yeah, sure. And then I'll open this other one where we'll do a mix of datums. Once this guy opens here, it's the same deal. I have my mesh. I do not have a model, so I will go into import, CAD model, and pick my sample casting IGES. That's now opened in space. Just like last time, we would need to do a best fit to reference objects. I can use the automatic pre-align, and I'm aligning all data objects, surface data objects, to the sample casting IGES. Looks pretty good. Hit start. Now that's done for me. They look pretty good. I'll close that. But now this time I'll create the same A datums, but I'll use the numeric method for that. So to do that, I'm going to hide my data and go back into reference targets and surface reference target points. We'll call this A, but method I'm going to change to numerically. Now, if I knew all 3 numbers, I can type in all 3 XYZ numbers, but I want it to project in the direction we're looking, which if we look at the trihedron in the lower left corner there, it's we're facing the Z positive. So if I click the project button, and projected in Z, I should be able to type in those points. So looking here at my blueprint, essentially, we're looking at A1 as -50 and -77. So I'll just key those in, -50, -77. Alignment direction is automatic, and if I create that, we can see it has appeared where it should appear. The next point, 2, is -50 and then +73. It's already incrementing across the top here, A2. So I'll just hit create, and now it's made A2 at that location. A3 would be 135 and 0. So we'll enter those in, 135, 0, and I'm projecting onto Z, create. So that's my A3 targets. So in this scenario, my print has 3 A targets, but it's going to call these 2 holes here as my B and C targets are the through holes. So in that case, I would need to create a feature, a circular feature rather than a point. So if I go across the top here until I find create features, it opens this dialog box, and the first type here is multiple types. So I could be able to come through and pick my circles, but with the multiple types, you got to be careful. You see it change from a plane to a cylinder to that circle. So I'll undo. Or we can just tell it ahead of time we are doing circles. The method is to pick off the CAD model. And because I chose this to be pick off circles, I have this datum feature label where I can go in and actually call it B before even picking it. B, and then I can call it C, but I'm gonna not do that so that I can show how to if you forgot to. So see there, it says circle 1, and I've noticed I forgot to give it a datum label. So to do that would be to right click the circle 1, go to properties, and then it's right here across the top, datum feature label. I'll go ahead and call it C, apply, close. So now I have my 3 A points, my B datum, my C datum, and only thing I need left to do is to highlight them in the tree, to right click them, and extract measured. So now I need to measure them after I pick them off CAD. So that's done. It gives me my deviation from CAD, the measured. So I'll go ahead and show the measured, and then now we'll go into the alignments drop down to the bottom to datum reference frame alignment, creation, ABC, create it, and then align to it. There we go. So now the part has virtually been fixtured on a fixture that coincides with ABC. So either way that we pick the datums or the targets for the alignment, we get it to this point and then color map it. So we have the color map icon across the top. It's the cube with the rainbow. And then our options in here, we have a few options, but we want to do the surface one. So data object deviations from reference object surfaces. The other ones are for edges and clearances and things like that. Direction of the color map. Usually you want to go shortest because that is the direction that the CAD face is facing, but you also have the option to go along an axis to color it in X, Y, or Z axis. Reference objects, we only have one, but if we had a couple CAD models in here, we could choose to specify one or the other. data object, same, it's surfaces, but if we had multiple, we could specify. Max distance is the maximum distance from the CAD that it considers data, and 4 millimeters seems pretty good. You get away with less on this part, but if it were a part thinner plastic that deviated a lot, that number is adjustable. Then we click the measure button. And we have a color map. So I'll close that dialog box, have my tree over here. We can see deviation to surface 1 is the name of the color map. We're looking here. I'm not running the default color map, so let me bump it to what a default color map. So this would be the default color map. So it's an auto range based on that 4 millimeter max distance. So that's what that looks like. So these icons over to the right here, there's 3 right in the middle. The top one is hide and show the color. The middle is create color map annotation points. So that allows me to go click anywhere and get real-time deviation. And then the third one is edit color scale. So that's what I have open on screen here. So I'd like to talk about a couple of these color scales. What we're at is auto range. So it's just auto ranging based on an automatic limit that it has in the middle here. There are also a handful of built ones in here. If you needed to build your own, you could just go click on the bar, and I can click these sections and change what their colors are, or how many increments are in there. With the range limits, I can go to custom, and maybe I want to see this as 2 millimeters, and I'll hit apply. Didn't change a whole lot. Maybe I want to see it as 1 millimeter. Hit apply. So we can see it got a little more blue around here and a little more yellow here, not a whole lot. See, 0.5 millimeters. So now we really got a big difference in color at 0.5. We actually have some that is gray, which means it's outside of the range of a 0.5 millimeter. So that'd be a failing mark or something like that. People tend to like in the scale types the Rainbow 240, simply because on this one, at the 0 mark, if it were plus 1,000th, it'd be green. If it were minus 1,000th, it'd clearly be blue. It's a huge drop, and the Rainbow 240 one has more of a blend between 0 and plus minus. The color still changes, but it doesn't change that dramatically. So this, and I'll go to the 0.5 on the auto range. This is the same color map as the last one, but it's not as abrasive across the top, I guess, since the top is only, minus 50 microns and plus 20 microns. That would have been blue and green in the last color map. And the object tolerances is another color map. So that's the conversion to colors. That's this top bar. Object tolerances is based on the CAD surface, and it's a tolerance associated to each CAD surface. And this one, the most likely is the pass-fail. So looking here, if 0.5 millimeter were our tolerance, it's showing us in red where the fail marks are. Yeah, and then there's the rainbow that does have pass-fail with a different color for minus and max, and then rainbow in between. So with this color map, you don't get numbers as far as the colors. You get whether it's 0 or getting warmer, getting to tolerance, or out between upper tolerance and maximum. And then there is use custom color scale, customized color scale. So that's what I have here. I just built, if you look, a green to orange rainbow and a green to purple rainbow going downward. And at any time I want, I can click here in this box, which opens up my scale editor, and I can right click on these little triangles in the little gray triangles on the scale and type the values I want. So, you know, this is 0.5, it looks good, 0.5 down below, and then apply. I guess I didn't have to change anything. So this is my customized scale with the 0.5 millimeter pass fail. So I got some red there. Looks like it might be some flash or something. I don't know what. Or no, the radius isn't big enough. And definitely these are on the low side. And then looking inside, that's where we see the most deviation. Which it's always, I like the thin-walled stuff because you can easily tell this side is below where it should be, and right on the inside it's above where it should be. And that rib's off look, it's too thick, too thin. It's below stock, yep. So the color map can tell you a lot just like that. And then one final thing here is to the left on my tree, I have the alignment group with all the different alignments. So if I wanted to see this very same color scale as the best fit, not as the datums, I can highlight it, right click and go to activate. Makes that the bold one and updates. I don't know if you saw that change, but it did change ever so slightly. Updates the color map. So good for analytics to find out maybe I didn't have enough stock in the datum alignment, but in the best fit I do have enough stock. So at this point we can look at the reference targets and note that there's a good part in there, but not when the datums are where they should be. So this could indicate to us that that's above stock 187 right now. So if we ground off that area a little bit more and then put it back in the fixture, that there might be enough to machine. So that's what I have for you guys. Is there any quick questions from anyone?
Are cross sections pretty easy?
Yeah, I can show that real quick. The easiest ones are just from standard axis. So that's this rubber band looking icon. So cross sections. I'll grab the first one, create a standard cross section, and then here it's from along an axis. So if I want to cut it in X, Y, or Z, there is a preview which shows me what and where I'm cutting. So maybe I want to cut that in Y. And there's a value here I can type in, or I can pick a location to cut. And I'll leave that at 0. Right down the middle looks pretty good. And then I just create it, hit confirm. And it's made here. So if I hide the mesh, and hide the data and hide the CAD, there's my cross section. You got to zoom pretty far in here. Oh, here we go. Let me change the color of the mesh real quick. It doesn't look very, there we go. Orange is the scan and blue is the CAD. So we can look at that same deviation. If I turn back on the color map, here with the icon to the right, I get a whisker plot of that deviation that matches up with the color from the scan. Any other questions?
Thanks a lot for presenting today, Phil.
No problem. Again, I'll show real quick. My desktop has my business card. If anybody sees this WebEx in the future or has questions, there's my contact info with my email and my mobile number. Thanks, everybody, for joining.
All right.
Thanks, Phil.
Thank you.
Thank you.